Hello everyone, my name is Andrew. Today we continue learning about blockchain, and today we'll write our own smart contract in Ethereum. So let's start. But before we begin with that video, I want to say that it's really important that you understand basics of coding, programming, and most importantly blockchain. Because if you have not been able to work or understand those technologies, then it's going to be really hard for you to follow what I'm about to say. But if you are familiar with the coding, with blockchain and all that stuff, then just watch that video till the end. The most popular blockchain nowadays is Bitcoin. And there is one big problem with that cryptocurrency, is that Bitcoin is not Turing complete. So we can't really write any logic that we wish on that blockchain. And in modern world, that is an enormous problem, because maybe we want to impose some rules on specific users. So when they want to send some money to another wallet, they need to follow up some procedures, or they need to do something in order to send assets to another user of that cryptocurrency. And in order to do that, smart contracts were created. So basically a smart contract is an application on the blockchain. The only thing that you need to do is write some code and deploy it. The same as you do it with normal Python, JavaScript, Java, or any other language. You just write some code and you deploy it. But here the main difference is that your code will work on the blockchain, and you can do whatever you want with that blockchain and even with the outer world. That is the whole idea of smart contracts on the blockchain. Today we'll create a wallet, so our users can send money to that wallet, but only the owner of that wallet can retrieve that money from it. That is it, and let's just start with our code. Now let's write our first smart contract, and for that purpose I will open a Remix IDE. It's just a website, you can go on it, link is in the description, you can go on it and write smart contracts, play with them, and even deploy them to the real Ethereum, Binance chain, or any network. But for now we'll just deploy our first smart contract to a testnet. So what do we have here? That is Remix ID, and there are a bunch of sections, but the most important one is the file explorer. And here we have, I think, 5 folders, but let's open up contracts, and I'll create a new file called wallet.so here. So contracts is the folder that contains all of our contracts, and wallet.so is the name of our first contract. So wallet is the name, capitalized, which is important, and .so is the extension of Solidity programming language. The first thing that we are supposed to do in a smart contract is request the version of Solidity. So what version are you supposed to use in order to deploy that smart contract? In our case, what we need to write is pragma Solidity. So get Solidity version, which is 0.8.12. All of the versions can be found in the Solidity Compiler right here, and let me just close that another window so we don't get distracted. So Solidity Compiler right here, and you have a bunch of versions starting from 0.1.1 going all the way to 0.8, 0.12. You don't need to write all of that plus commit and commit hash, but you just need to write the number, and that's it. So now we're using the latest version, which is available here, which is Solidity 0.8.12. For you it may be different, but I don't think that you experience any troubles if you just use the same version as me. Okay, now let's create our smart contract. In order to do that, I'll write contract and then wallet capitalized, and I'll open curly braces. You can have as many contracts as you wish for one file, so I can write contract ABC here and all of that stuff, but let's just use our contract wallet. And what are we supposed to do right here? So the idea of our wallet is that anybody can send money to us, but only the owner can get the money from the wallet. And the first thing that we are supposed to do is get the owner of the wallet. And in Solidity, every variable, every return, everything is strictly typed. So what do I mean by that? Every variable has a type, and you cannot change it midway. So type of our owner is address, because someone created that smart contract, so someone deployed it, and we need to get the address of that deployer, so of the person who created our application. And in order to do that, what I will do is write address, so that is the type of our variable, and owner is the name. Nothing fancy here. And now let's assign our owner to some address. But there is a problem. If we go to the Solidity deploy and run transactions, you can see a bunch of stuff, but for now let's look at account. So account are all the accounts that are provided to you. So all of the accounts are test ones. As you can see, we have a lot of ether on all of those, and there is a problem. We need to dynamically change the person who is creating our smart contract, because what I can do is create my wallet from 0x5, then create it from 0x0 or 0. So my wallet can change, and what I need to do is dynamically assign my owner to the person who really deployed that application. And how can we do that? In smart contracts, we have a special function called constructor. I think all of you know about it because I talked about it, but for beginners, constructor is the function that is called when you create something. In our case, we create our smart contract. And what we can do here is use a special variable called msg, so message. Message has a lot of stuff, but for that video, we're going to use value and message sender. So value is how much Ethereum, how much BNB, how much of a coin did we send with that transaction. And message.sender is the address of the person who really created that transaction. So if you think about that, whenever I deploy my smart contract, I create a transaction because I change the state of the blockchain. I create some new Dapp. And because of that, in constructor, message sender is always the wallet that created that application. And what we can actually do is just assign owner to message.sender. So our owner will be the person who created that contract, because once again, in constructor, message sender is the deployer of that application. Very cool. Okay, so now we have our constructor and owner equals to message.sender. What do we need to do now? Now let's create our first function, which will allow our users to add some funds to our wallet. So I will write function add funds like that. And aside from normal C representation of a function creation, what we need to do is also provide a visibility modifier. So visibility modifier tells you who can use your function. If you worked with object-oriented programming before, then it's just the private, public, all that stuff. So encapsulation of your variables and functions. The same goes with Solidity. So what do we have here? For now, let's just use private and public modifiers. And the difference between those is that private modifier tells us that only the contract itself can call that function. So no one except for the contract, except for the application, can invoke add funds function. But public tells that everyone can use that function, and in order to add funds to our wallet, I think that we'll need to provide public as our visibility modifier, because I want anyone on the blockchain to send money to my wallet. Okay, so add funds, public, everything works perfectly. Now let's create a variable of type uint, and that variable is going to be called balance. So balance is the variable that is going to have all of the money that is on our wallet. There are some other ways of how we can get the balance of the smart contract, but for now, we're just going to track it in our balance variable. So what is uint for those of you who don't know? Uint stands for unsigned integer. So what is unsigned? Unsigned basically means that you cannot have negative values. And there is a reason for that, because our balance cannot be negative. We don't trade Bitcoin, we only hold it. And because of that, I'm using uinteger. Aside from just removing all of the negative values, you have a lot more positive values, because you basically shift your range, so your value range from negative to a lot more positive values in your integer. So for example, I can have 10 trillion here if I'm using, or something like that, if I'm using a uinteger, but I can't do it with integer, because integer also has negative values in it. But if we think about that, balance cannot be negative, so we're only using uinteger here. And now what we need to do is use balance plus equals message.value. But there is a problem. So as you can see, there is a red warning here, and it basically says that something is not right with that function. Every function in Solidity has a lot of modifiers, and those modifiers are used in order to reduce the cost of transactions. In our case, we need to provide a modifier called payable. So we make our transaction payable. So users can send money to each other, and that function add funds will be able to work with some kind of money, some form of asset, and so on. In our case, we are saying that add funds function will be payable, and because of that, I can use message.value. Because if my function is not payable, I cannot send any Ether, any BNB, or any other coin to my smart contract. Because again, those modifiers are used to decrease the cost of your transactions, and we can finally go here, and as you can see, message value can only be used in payable functions. So we need to really make it payable in order to receive some crypto in our add funds. And I think for now add funds is done. So what we have here is balance, and we just increase our balance by message.value. And now let's deploy our smart contract and see where we're at. Before we do that, let's quickly go through all of those inputs. And the first one is environment. So you have different environments. You can use Web3 provider in order to connect to your MetaMask wallet or any other wallet in your browser. But for now, we're just going to use JavaScript VM. Then, as I said, we have testing accounts and gas limit. So how much gas do you want to spend on one transaction? Don't change it for now, just leave it as it is. The second, or the next value is value, and that stands for the amount of cryptocurrency that we are gonna send to our contract. So as you can see, here is 0, but if I want to send, for example, 10 Ethereum, I can write 10 here, and it will send 10, but not Ethereum. As you can see, we have way, so I need to change it to Ether. So now, if I will use my transaction, I'll send 10 Ether to my smart contract or to any other user. But there is also a drop down here which tells you Way, Gwei, Fini, and Ether. A lot of you may know about Ether, basically it's Ethereum, but what are those three? Whenever we work with smart contracts in blockchain, we don't really use Ethereum as a base currency. So in your wallet, you may have 0.3 Ethereum, but actually for the blockchain, you don't have any Ethereum. You have Way, because Way is the lowest amount of crypto in Ethereum blockchain. The same goes for other blockchains, for example, Satoshi for Bitcoin. And the only difference in those is the amount of Way they represent. So for example, Ether represents 1 to 10 in 18th power Way. And basically developers of a blockchain did it in order to avoid all of the intermediate values. So we don't work with floats, doubles, and all that stuff in blockchain. If you want to send 0.1 Ether, you just go here, you just go 0.1, or you can even write 0.1 here. But you can send 0.1 Ether and it will be serialized in Way. So you have like 0.1, I think that maybe that much Way, so a lot of Way. That is the whole idea. We don't work with float and double values, we only work with Way, which is translated from Gwei, Fini, Ether, and all the other values. So those are the most popular ones. Alright, so for now I'm just gonna write 0 Way, and the next drop down is contract. For now we only have one contract wallet, so, and let's deploy it. So deploy, as you can see, we have deployed contracts here, and we have our wallet at some address. Alright, so as you can see, we have our deployed contract here, and let's add some funds. I'm gonna click on add funds. As you can see in my console, it says that from some wallet to wallet add funds. So we really send our transaction, but now let's send some Way to our wallet. So as you can see, my balance is 9999, so let's go at 85. I'm gonna send 10 Way to my wallet. Let's send it, and now as you can see, 93. So we have a lot less Ethereum that we had before. Now let's send like 10 Ether. 10 Ether, add funds. As you can see, I only have 80 Ether in my account right now because I sent all of that to my smart contract. And now my smart contract has like 18 Ethereum and 10 Wei in it. But in order to see the balance of our smart contract, what we need to do is either create a function that will return that balance or make our balance public. Because as I said, those modifiers, so visibility modifiers, are used for both functions and variables. And let's just put public in here. So int public balance. Now, if I deploy my smart contract once again, I can see that instead of one add funds button, I have two, add funds and balance. If I click on balance, I receive 0. But if I add some ether to my application, so add funds, as you can see, I receive ether in Wei. So you can count, there are 18 zeros in here, and you send one ether and it was translated to Wei. That is really, really cool. Let's send, I don't know, like 1 to 3 Wei, add funds, balance, and as you can see, I think I only wrote 2 or 3 here. As you can see, I received 23 Wei on top of that. So really our wallet works, and so our wallet really works, and everything is fine with our balance. But now let's create the most important function, which will allow us to get money from that smart contract. I'm gonna say function. I'm gonna create a function. I'm gonna create a function called get funds, and it's gonna be a public function, also payable, because we will need to send the money to our owner. But there is one catch. What we need to do is not just send money, but we need to check that the person who invokes that transaction really is the owner of that smart contract. Because if someone finds that wallet on the blockchain and just says, oh, all right, it has like 10 ether, let me just get it, that is not all right. So what we need to do is use ifs. If, and what do we write here? Message.sender. Remember that message.sender is the person who invokes or sends the transaction. If message.sender equals owner, which we assigned in constructor, then we need to transfer our money. But else, we need to revert. And the revert function is the function that you're using when you want to cancel your transaction. So message is sender of that message is not an owner, so we need to revert that transaction. That's how it works. But if message.sender is the owner, what we need to do next is send some money from our wallet to the owner. But what if I don't want to get all of my balance at once? I want to get, for example, 10 ether out of 100. What I need to do is create a new variable called uint amount, and that amount will show us what is the value that we want to get from our wallet. So what we need to do right now, we need to transfer money from our contract to the owner. And in order to do that, I'm gonna say payable from owner dot transfer amount, like that. So why do we need to use payable and what is transfer? Our owner is just an address, so address owner. But in order to send some ether to that address, we need to convert it to a payable address. And in order to do that, we just use payable and parentheses with our address inside. And then what we can use is a transfer function that will send some ether from our owner to, or from our smart contract, in that case, to our owner. And the amount is how much ether, or how much Wei, if we are precise, we want to send to that user. But what we need to do in advance is subtract that amount from balance. And we need to do that in order to update our balance, because if I had like 10 ether, I got 8 out of my wallet, I need to have 2 ether in my wallet. I don't need to have 10, because 8 of those coins were transferred to my account. And in order to do that, we need to subtract amount from our balance. All right, so now let's just test our smart contract. I'm gonna press deploy, and now we have 3 functions with 2 functions and 1 variable with int 256 amount in here. Okay, so first of all, let's check our balance. 0, yeah, because we have no ether, have no way, we have nothing in our wallet. Let's add 1 ether. So as you can see, 78, my balance is slowly decreasing. And then let's get our funds from that wallet. So as you can see, I have a lot of ether in here. So I only have 1, but I have a lot of way in here. And let's get somewhere around that. So get funds. And now, as you can see, my balance decreased. So let's actually send some more ether. I'm gonna send like 100 ether, not 100, but 99. As you can see, I changed my account. For example, our friend sends us some money, and now we only have 0.99999 ether. So we don't even have 1 Ethereum in our wallet. And I'm gonna change to the owner of that contract. Let's check our balance. So as you can see, a lot more zeros. And let's get all of that from the wallet to our own balance. Get funds. And as you can see, we have 178 ether. Pretty good. Now what I want to do is check if I can invoke that get funds function from my other account. So get funds. As you can see, it says revert, and we have a warning sign here, so cross here, and it says that our transaction was reverted. Why is that? Because we are not an owner of that wallet. So basically that's it. That is our first smart contract, and it's pretty easy, but there are some things that we can improve in that smart contract. For example, add comments or add the version, or even omit that balance variable. So there are a lot of things that we can improve, but for now, that is the perfect way to start working on your Solidity, on your smart contracts. And thank you for watching. My name is Andrew. Subscribe to my channel, leave a like, leave a comment. Tell me if you wanna see any of the smart contract stuff in the future. And thank you. Bye bye and good luck.